Welcome.
We're good. Hopefully the others show up, but yeah.
All right. Do you have any questions on the prep?
I do not have any questions about the prep. Do you have any questions about the prep?
I do not have any questions about the prep.
All
So we
right,
should
let's move
just
on to the
start the
quiz.
quiz.
All
Yeah.
right, cool.
Is it just the two of you?
Currently.
Oh.
Question 3, I put that which hypothesis involves equality? It's the null hypothesis.
Yep, that's the one that is currently accepted.
All right. Question 4, remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. In computing the p-value, which hypothesis do you assume to be true? The null hypothesis?
Yes.
All right.
What did she do?
Which of the following represents the alternative hypothesis for at least for a two-tailed test? I put that mu does not equal 10.
Yep.
All right. Which of the following represents the alternative hypothesis for a left-tailed test? That is when mu is less than 10. So what you put?
Yes. And then 7 is mu is greater than 10. Right tail test.
Yep. The relationship, which result should result in failing to reject the null hypothesis? That's when the p-value is greater than alpha.
Yeah.
All right. And then the opposite of that for question 9.
Which relationship is it? Yeah, less than alpha. Yep. 10. Spencer's here.
Oh, Spencer. Spencer? Spencer, are you actually here?
Who's that?
There he is. Can everybody hear everybody?
Yeah, I can hear you guys.
I can hear Spencer, but he's very, very quiet.
I can hear both of you pretty good.
Okay.
Cool. So Spencer, we were just going through the quiz, and so we can catch you up if you want.
Do you have any questions about the prep?
It was epic, bro.
Oh yeah, for sure. No. Let me just pull it up. Sorry, I'm gonna let you guys. Oh yeah, it wants to be slow.
Did Mackenzie say that she wasn't going to be? No, she didn't say anything. But...
No, I thought she was gonna be on the call.
I did too.
Yeah, she didn't say anything, so.
Just keep going. Keep pushing on the quiz. I'm gonna have to close my browser and bring it back up because it's being real slow. See you guys in a second.
Okay. So where were we? Question 10?
Question 10. So an insurance company is reviewing its current policy rates when originally setting the rates they believe the average claim was about $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be appropriate alternative hypothesis that the average claim is greater than 1,500?
Yep. And then 11 is it's equal to, because that's the null hypothesis.
Yep. And then 12, the insurance company randomly selects 40 claims and calculates a sample mean of 1650. this information to answer the next three questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? I put that it is a good assumption because the sample size is large enough.
Yep. And is that the law of large numbers?
I think so, or is it the? Yeah, could be.
Because the central limit theorem is if the sample size is large, then the sample mean equals the population mean.
Is that the central limit theorem?
Pretty sure.
I think that the central limit theorem is that it approaches normality. Isn't it?
Again, the quiz, yeah. Are you sure? I feel like that's backwards. Don't be selling me down the river. My roommate's in this class, and he thinks it's the central limit theorem, but
I
I'm not
also
sure.
think it's the central limit theorem.
I think you're full of crack.
So if you go to 4.6,
I think that's just a little bit.
Sorry, where am I going?
if you look at the textbook in 4.6 requirements, it's like 2/3 the way down.
Will you just read it to me?
Yeah, it says in the reading for distribution of sample means and the central limit theorem, we learned that, oh, maybe that's just referencing that section. Hang on, let me go read that section.
I'm just gonna look it up.
Is this lesson 9, by the way?
Yes.
That one? Yeah, okay. All right, I'll just jump into the question you guys are at. Which number are you guys on?
We are arguing over question 13.
13, okay. What theorem or law justifies your answer to this question?
Most situations, when independent random variables are added, they properly normalize sum tends toward a normal distribution, even if the original variables themselves are not normally distributed.
So the textbook in lesson 6, section 3, the central limit theorem says if the sample size is large, the random variable of x bar x will be approximately normally distributed. In other words, the sample distribution
Whatever.
the sample mean
I'm gonna
will be
get these
approximately
things mixed up
normal
for the
if the
rest of my
sample
life.
size is sufficiently large.
All you did was tell me that Evan was right, and I have to live with that guy.
I'm sorry. So Spencer, do you have any questions on anything?
Just what did you guys get for 12 so I can kind of
12 we
understand
put
13?
that it is a good assumption since the sample
Since
size
the
is
episode
large.
was large. Okay. And then do you guys think 13's, so is it the law of large numbers or no?
It's the central limit theorem.
And why is that?
Because the central limit theorem states that if you have a large enough sample size that the graph will approximate normality.
Okay.
So
All right.
the law of large numbers is the opposite of that then, right? So if you have a lot of sample sizes, then it equals the mean. The mean equals the mean, right?
Something like that, yes.
Something like that. That's helpful.
I'm sorry.
Yeah.
13.
Look at that.
I got-
Maybe Evan did that for you.
Thank you, Evan. I got Z-score for number 14.
Okay.
I also put Z for number
Yeah.
14.
Okay, I haven't gotten to 15 yet. So.
15, and I don't know that this is entirely correct, but I put negative 0.9.
Okay, 150 with a standard deviation of 40. The store manager just expressed that the average has decreased. So she thinks it's less than 150. Significance of 0.05. She takes the sample random 36 sales and gets 144. So
This is
Let me tell you
14.
what I did. I took 144 and I subtracted 150 from it. And then I divided that by 40 over the square root of 36.
which is 6. 40 divided by 6 is 6.6666666.
So
Negative 0.9.
that's what I got, yeah.
Okay,
Does that sound right to everybody?
that's what I got.
Okay.
Did you get an answer for 15, Spencer?
I just followed what David was saying.
Okay, cool.
Yeah.
16.
Question 16, what is the p-value associated with the z-score from the previous question? So I put 0.184 because I
How do you-
think how you do that
how
is
do you
you put
find
that
that?
in the normal
Yeah.
probability applet.
Oh.
And is this because she thinks the number is less than 150 that you only do the left side of the.
Yes, that's why I did that.
Okay, because, yeah. So that's like a left-tailed 1, right?
Yep.
Okay.
So what inference would you make about the null hypothesis?
Put reject the null.
No, you would
That's-
keep it
Would you?
because the p-score is higher than the level of significance. It means that the probability of getting that same result is high enough that. Hold on a second. Question 8. It's the answer to question 8.
Okay.
You would fail to reject the null hypothesis if the p-value is greater than alpha, and in this case, the p-value is greater than alpha.
All right.
Does that make sense, Spencer?
Yeah. Well, sort of.
So the p-value is the probability
Uh-huh.
that the sample size you collected, the mean of that, was random, like it could happen again. That's what the p-value says. And if the p-value is really big, then, so like in this case, the p-value is 18%. That means there's an 18% chance that you could get that same number randomly again. And that means that there's not enough evidence to say that the original mean is wrong or the original hypothesis is wrong.
Okay.
If the p-value is really small, it means the odds of getting that same that same mean is extremely rare, and so the original hypothesis is probably false.
Okay. That makes sense.
Cool.
Hey guys.
Hey, Mackenzie. We're on question 18 on the quiz, but we can go back over it all.
Yeah, don't worry. I was late too, so they're gonna go back over it.
18. You say you're on question 18?
Yes.
Yeah, Spencer got here when we were on question like 10, so we'll go
They
back
said
over.
they said they're not gonna go back over it, Mackenzie, so we're done for.
Oh,
Yep.
okay, cool. We're screwed. Hey, you
We
want to know something really quickly? Let's talk about the fact that I accidentally opened up the wrong group quiz, and it won't let you start another one until you finish that one. So I had to take that one by myself, and there's not very many questions. So if you miss like one, then you completely fail this quiz. Oh my gosh.
Was that for 10?
I don't remember. I think it was for either 10 or 11. I don't remember.
Oh.
But I was like, anyway, it was a real kick in the face. But go ahead, continue. I apologize.
No, you're good. We're glad you made it. So question 18 says, what is your conclusion for this problem?
But we have sufficient evidence that the true population mean is less than 150, or we don't have.
I know I can tell you what to do.
Whoa!
We have sufficient evidence that the true.
So because I thought that we were rejecting it, but we're not. So we don't have sufficient evidence. Otherwise, we would have rejected it.
I think the most correct answer here is we have insufficient evidence that the true population mean is less than 150.
Okay.
Because that's what we proved wrong, is that it's not less than 150.
Right.
But we don't know if it's greater than 150. So
But if we proved it wrong, then shouldn't we know that it's greater than 150?
either that or it equals 150.
Oh.
I think the most correct answer is C.
Okay. So question 19, there are two types of errors that can be made in performing a hypothesis test. Which one involves rejecting the null hypothesis when it's true? I put type 1.
Yeah. Null hypothesis is true and you reject it as type 1. null hypothesis is false and you accept it is type 2. Right?
Yeah.
So this is a type 1.
Yep.
That's still like, it confuses my brain, but okay.
So a researcher decided that instead of using a level of significance of 0.05, he will use a level of significance of 0.01. Which of the following is true? I put the probability of a type 2 error will increase.
If you make that means the p-value has to be smaller to make a type 2 error. Man, this really racks my brain.
So the textbook says that if the alpha value is very small, the probability of committing a type 2 error will be large. So the smaller alpha is, then the greater the probability of committing the error is.
Yeah, and that's because you'd need a p-value that's extremely small in order to reject
Yeah.
the null hypothesis, even if the null hypothesis was false, which is what a type 2 error is. Okay.
Yeah.
Okay, that makes sense, kind of, sort of, maybe. Okay, question 21. If alpha is 0.5, compute the probability of committing a type 1 error. That's
I put 0.05. Somewhere in the text I read that alpha is essentially the probability of committing a type 1 error.
yeah, yep, it's 5 out of 100. Did you submit this quiz yet?
I have not.
All right, I'll submit it. We'll see what happens.
Should we go back over it with
Yeah, I mean, we can go look at it for sure, but I just want to see how we did.
Okay, go ahead.
Okay, we aced it, so that's a good sign.
Did we?
Yeah. Yeah.
Not us.
All right. Can you guys, question 1 and 2 are tricky if you guys want to help me out with those ones.
Yeah,
Yeah.
so those ones are really they're just kind of like based
Both
on
of them are false.
Both of them are false.
This involves equality. Number 3, that true hypothesis? No, null hypothesis, right?
It's the null, yep.
Yeah.
You assume the null hypothesis, right?
Yep.
Yep.
Two-tailed test. What did you guys get for 5? I'm not sure.
5 is not equals.
Oh, that's what I put, but I did not know why. This is for two-tailed test.
So a left-tailed is when the mean, they think the mean is less than. A right-tailed is when they think it's greater than. And two-tailed would be both of those, which is, it just doesn't equal 10. It could be greater, could be less.
Gotcha. Okay. And then for number 6, is it less? Is it equals then, or is it
Mu is less than 10. for
less
number
than 10?
6. So
Okay.
it's left-tailed, we reject the null and accept the alternative
Alternative.
if it's less. And then
Gotcha.
right-tailed if it's greater.
Okay. So then right-tailed is greater than.
Mm-hmm. Yep.
Okay, which relationship? Which is null hypothesis? I have no idea on question 8.
So question 8 is A, p-value is greater than alpha. And alpha is, it's the level of significance. And so what you're saying is, if the p-value is less than this number, then you're like, your experiment has value. But if it's bigger than this number, then you really have shown nothing. And
That
so
makes sense.
since the p-value, the probability value is greater,
Yeah.
then we fail to reject, which is the same as saying we accept the null hypothesis.
Yeah.
Just stupid.
Well, yeah, it's
Does that
two
make sense?
negatives failing to reject.
Yeah.
Okay. So sorry. So it's greater than, right?
Yeah,
Yeah.
P is greater than alpha, and then number 9 is P is less than alpha because it's the
Less
opposite.
than alpha. Yeah, that's the opposite.
Guys, you're cutting out. I can't hear you.
What'd she say?
She says we're cutting out. Can you hear me now?
Yeah, I can kind of hear you. For
Where are
number
you at?
8, I put P value is greater than alpha.
Yep, that's right.
That's correct.
Okay, what about number 9?
The opposite of that, when P is less than alpha.
Okay, that's what I thought. How does one do that?
10.
I just like I am weak right now. Like part of me is like, just come over. Like come over and spend time with me.
So would it be the average claim amount is greater than 1,500?
Yep, that's correct.
All right. Which of the following would be appropriate? No hypothesis. No hypothesis. The average claim amount is. And would it be the same in 11? Would you assume the null hypothesis?
No, 11 is when it's equal to. So the null hypothesis is that pretty much nothing changes. So if we already think that it's 1,500, the null hypothesis is that it's equal to 1,500.
It's equal to 1,500, which makes sense. Cool. Well, I'm caught up.
All right, Mackenzie, still on 12.
I'm not caught up yet. One on the 12.
Okay.
The insurance company assumes distribution of sample mean is normal. Is this a good assumption? Yes, it is a good assumption because the sample size is large enough.
Grande.
And that's the large numbers or the central limit theorem?
It's the central limit theorem.
We argued about that, Mackenzie, for like 15 minutes before you showed up.
It's
You know what? At this point, it's like a 50-50 guess for me. I'm like, every time I think it's large numbers, it's central limit. Every time I think it's central limit, it's large numbers.
Yep, same.
Okay, what about
Every
14?
time.
the test statistic is defined as Z.
I can't hear you. What did you just say?
Z.
Z.
That was awesome, Taylor. Can you do that again?
Yeah, I can't. It's like this.
Okay, and then can someone do the math for me on these ones so I don't have to do it, or do you really want me to do it?
Do you know how to do it? That's the most important part.
What is the z-score associated with this test? Did you guys put that one in the applet?
No, the Z-score is what you find by taking the mean that you have, or the value that you have, subtracting it from the mean, and then dividing that
By the
by
standard.
the standard deviation divided
Okay.
by the square root of the population,
Okay.
or the sample size, not the population.
What is the p-value associated with the z-score? Okay, I know how to do the first one, but I don't know how to do the
Okay,
second.
I have to head out, but thanks for your help today. I'll see you guys later.
Okay, we'll
Bye,
see you,
Spencer.
Spencer.
So for 16, you just put it in the normal probability applet.
Mhm.
And then
Oh,
you get
that's the one we put in the applet.
Yep.
Okay.
So 15 is negative 0.9 and 16 is 0.184.
What inference would you make about the null hypothesis for this problem? Let me look at it.
My laptop might die soon, but I'll be okay.
You guys fail to reject.
Yep, that's correct.
Okay.
You caught up?
I think that's the last one I needed. Yep, I'm good.
Awesome.
Hey guys, just a reminder really quickly. I'm gone next week and the following week because I'm getting married and going on my honeymoon. So
Okay.
you won't see me for the next 4 group meetings.
Congratulations.
Thank
Have
you.
fun.
Enjoy it.
I will. See you guys later. Thank you so much.
We'll see ya.
See ya.
Bye.
I'm going to stop this broadcast.